Hi, my name is Thomas Edwards. I'm Vice President of Engineering and Development in the Advanced Technology Group of Fox Network Engineering and Operations. At Fox, we are very interested in driving towards a next-generation infrastructure in the broadcast plant. Legacy broadcast audio-video technology is centered around SDI, the Serial Digital Interface, which carries a single unidirectional media stream on a physical piece of coaxial cable. As a result, today's broadcast plant includes miles of cable and expensive video routing devices that are specially built only for the broadcast industry. Our vision is to take advantage of the commercial off-the-shelf Ethernet networking gear to build a much more flexible broadcast plant. Such a solution would combine traditional IT workflows with broadcast media onto one infrastructure to gain the efficiencies inherent in a converged plant. To make this evolution a reality, several elements are needed by the industry. First, we need standards on how uncompressed broadcast media streams will be encoded over the Ethernet. Today, there are two primary standards becoming popular in the industry: SMPTE 2022-6, which involves IP transport, and AVB, which is a Layer 2 approach. So this problem is rapidly being addressed through multiple efforts. Second, we need to be able to do some basic things that broadcast plants have always relied upon, such as seamless, glitch-free switching of video. You can't switch a video in the middle of a frame. It looks horrible. You have to switch during the blanking period between the frames. To achieve this, there has to be some awareness by the switching device of the video frame and the video raster, something that off-the-shelf Ethernet gear is not designed to do. From a very high level, there are three ways to perform seamless, frame-accurate video switching on a packetized Ethernet infrastructure. First, there's destination time switching. This is a make-before-break concept, where the receiving device subscribes to a second media stream, then performs a frame-accurate switching at a frame boundary, and then drops the original stream. The problem with this approach is that double the network bandwidth is being consumed at the endpoint, while both streams are being subscribed to, which means that fewer streams can be carried by the networking equipment. Second, there's network time switching. In this approach, the Ethernet gear itself is aware of the video payload and performs the switching. But this requires special Ethernet gear that isn't so off the shelf and can add to a lot of cost. Third, there is source time switching. With the source timed approach, the network is prepared in advance with new stream flows using software-defined networking technologies prior to the actual switching of video. And the media source, such as a camera, performs the precisely timed action of making a change to the media stream's packet headers to utilize the new flow steering that was pre-programmed into the network. Arista and Fox have actually implemented proof of concepts of both network-timed and source-timed video switching of uncompressed Ethernet media streams. The most recent was a demonstration of source-timed video switching using SDN on an Arista Ethernet switch. In this proof of concept, we had two media streams being converted to the SMPTE 2022-6 format and carried on an Ethernet network. An orchestration system would trigger a video switch through a multi-step process. First, it would prepare the Ethernet network for an upcoming change by programming new flow rules into the network using software-defined networking techniques. In this case, Arista's direct flow capability was used. Direct flow can be thought of as a controllerless open flow, allowing individual IP flows to be custom steered in the network. Then a change was triggered by the video sources at a precise point in the video frame, the SMPTE RP168 switching point, during the video blanking interval. This change in the packet headers carrying the video streams matches the newly programmed flow rules in the Ethernet network. For our proof of concept, we simply changed the UDP source port number. This proof of concept effectively demonstrated the viability of the source-timed switching concept and makes very efficient use of the network resources. Obviously, many things must occur in the industry before this is production ready for widespread deployment. But companies like Arista are providing technology that helps to achieve this vision and deliver the promise of a converged infrastructure based on Ethernet economics. We are very pleased to have Arista's participation in these two proofs of concepts and look forward to helping shape the industry's evolution towards the next generation broadcast plant architecture. Thank you for watching.